All right, hi you guys, good morning. We're going to be doing a really short video today to use a proportion to calculate what we call percent of error. You're going to find that this is pretty similar to how we calculate percent increase and decrease. Please take notes as we go. So the percent of error basically shows you the difference between an approximate or estimated value and the exact value, and it does it as a percent. We start by looking for the error. That's the difference. That should sound familiar to you because the difference is the same thing we calculate in a percent of change, right? The difference is the change between the estimated value and the actual or exact value. Here's an example. I estimated 260 people, but 325 came. So to find the error, we find the difference. We subtract 325 minus 260 to get 65. So the error is 65. Let's now see how that fits in to a proportion. To calculate the percent of error, we set up a proportion. Most of this should look really similar to what we've done before. Look over here on the left side. X over 100 is equal to error over the exact or actual number. So let's talk about what this means. We said that the error is the same thing as the difference between what you approximated or estimated and what actually happened over the exact number, right? So in the above example, we would do x over 100 is equal to 65, right? That's the difference in the number of people who were estimated and the number of people who came. And 325, which is the actual number of people who attended. Once we have this set up as a proportion, we know how to solve it. We're going to cross multiply to get 325x is equal to 6,500. We're going to divide both sides by 325 to solve for x. 325 goes into 6,500. Look at that. 20 times, so x equals 20. Let's talk about what that x actually tells us. We're finding the percent of error, so our answer is going to be written as a percent of error. So we write 20% error. So you know how with percent of change, we answer as a percent increase or a percent decrease? The same thing is true here. We answer as a percent error. Let's do one more example together. 70 people RSVP'd for a concert, but 80 people came. We're going to find the percent of error. That's why our x is in the percent spot. We're going to use the proportion x over 100 equals error over actual. So the first part of the proportion, easy, right? X over 100. Let's figure out what the error is. What's the change? What's the difference? Well, 80 came. We predicted 70 would. So our change, our error, is 10. How many people actually came? Look back at the problem. 80 people came, so we are going to put 80 in the denominator. So we've got x over 100 equals the error of 10 over the actual of 80. Now we're going to cross multiply and solve. 80x is equal to 1,000. Divide both sides by 80. I'm going to make that a little bit easier and slash some zeros. I'm going to go 8 into 100 is, I'm going to have a little bit of a remainder, but it's not a big deal because it's a nice easy 0.5. X is equal to 12.5. So think about how we're going to label it. We would say it is a percent of error is 12.5% or a 12.5% error. And that's it. Thanks, guys. Bye-bye.